For decades, Pluto was considered little more than a frozen relic at the edge of our solar system. After its reclassification as a dwarf planet in 2006, many assumed its story had ended. Instead, it may have only been beginning. Thanks to observations from the James Webb Space Telescope, combined with data gathered by NASA's New Horizons mission, scientists are taking a fresh look at this distant world. While Webb cannot capture close-up surface photographs like a spacecraft in orbit, its infrared observations are helping researchers better understand Pluto's atmosphere, surface chemistry, and temperature patterns. Every new piece of information adds another layer to an already fascinating mystery. One feature continues to attract enormous scientific attention: Sputnik Planitia, the vast heart-shaped basin that dominates Pluto's surface. This enormous plain is covered mainly by frozen nitrogen ice, along with methane and carbon monoxide. Although it appears calm from a distance, evidence suggests the ice slowly flows over time, almost like glaciers on Earth. Scientists believe this basin is so massive that it may have influenced Pluto's orientation, essentially changing how the dwarf planet settled in space. That alone makes Sputnik Planitia one of the most unusual geological structures ever discovered in the solar system. But the biggest mystery may lie far below the frozen surface. Many planetary scientists think Pluto could hide a deep underground ocean beneath its thick shell of ice. The idea may sound surprising for a world nearly 6 billion kilometers from the Sun, yet internal heat produced by the slow decay of radioactive elements inside Pluto's rocky core could keep water from freezing completely. If such an ocean exists, Pluto would join a growing list of icy worlds that may contain liquid water beneath their surfaces, including Europa and Enceladus. These hidden oceans are considered some of the most promising places to search for life beyond Earth. That doesn't mean scientists have discovered life on Pluto. They haven't. However, wherever liquid water, energy sources, and the right chemical ingredients come together, researchers naturally become interested because those conditions are considered important for life as we know it. Another clue comes from Pluto's surprisingly young-looking surface. When NASA's New Horizons spacecraft flew past Pluto in 2015, it revealed towering mountains made of water ice, enormous fractures stretching across the landscape, and regions with remarkably few impact craters. Normally, old worlds become heavily scarred over billions of years. Pluto's smoother regions suggest that parts of its surface have been renewed through geological activity. This raises an important question. Is Pluto still changing today? Scientists believe slow movements of ice, internal heat, and possible cryovolcanic activity, sometimes described as icy volcanism, could still be reshaping parts of the dwarf planet. Adding to the mystery is Pluto's largest moon, Charon. Unlike most planet-moon systems, Pluto and Charon orbit a common point located between them rather than inside Pluto itself. This unusual relationship causes both worlds to remain permanently facing each other. Some researchers think these gravitational interactions may have influenced Pluto's internal evolution over billions of years, although exactly how much heating they provide remains an active area of study. Webb's observations have also improved our understanding of Pluto's thin atmosphere. Although extremely faint, it contains mostly nitrogen, along with small amounts of methane and carbon monoxide. Sunlight triggers chemical reactions that create reddish organic particles called tholins, coating parts of Pluto's surface with its distinctive colors. These complex organic molecules are not living organisms, but they are scientifically important because similar compounds may have played a role in the early chemistry of many worlds. With every observation, Pluto becomes less like the frozen, inactive object many once imagined and more like a dynamic world that still has many secrets waiting beneath its icy crust. And perhaps the biggest questions are only beginning. As scientists continue studying Pluto, one conclusion is becoming increasingly clear: this distant dwarf planet is far more complex than anyone expected. The Kuiper Belt, the region beyond Neptune where Pluto resides, contains countless icy bodies left over from the birth of the solar system. Most were once thought to be frozen and inactive. Pluto appears different. Its moving nitrogen glaciers, layered atmosphere, unusual geology, and possible underground ocean make it one of the most intriguing destinations ever explored. If internal liquid water truly exists beneath Pluto's icy shell, it would dramatically expand our understanding of where potentially habitable environments might be found. Life, if it exists anywhere beyond Earth, would almost certainly look nothing like plants or animals. Scientists instead focus on the possibility of microscopic organisms capable of surviving in complete darkness, using chemical energy instead of sunlight. Similar environments exist deep beneath Earth's oceans around hydrothermal systems, proving that sunlight is not always required for life. Still, it is important to remember that there is currently no evidence that life exists on Pluto. The search remains entirely hypothetical. Another fascinating puzzle involves Pluto's atmosphere. As Pluto travels farther from and closer to the Sun during its long orbit, parts of its frozen surface slowly vaporize before freezing again. This seasonal cycle causes the atmosphere to expand and shrink over time, creating changes unlike anything seen on Earth. Meanwhile, Charon continues adding to the mystery. Its enormous canyons, fractured terrain, and strange reddish polar region hint at a dramatic geological past. Scientists think gases escaping from Pluto may eventually freeze onto Charon's poles, where sunlight transforms them into complex reddish organic compounds. This remarkable interaction shows that even distant icy worlds can influence one another over billions of years. The James Webb Space Telescope is now helping scientists analyze Pluto's surface materials with greater precision than ever before. Rather than taking close-up photographs, Webb studies how different materials absorb and emit infrared light, allowing researchers to identify various types of ice and organic compounds across Pluto's surface. These observations are improving models of Pluto's climate, chemistry, and seasonal evolution. Future exploration could answer even bigger questions. Many researchers hope that one day a dedicated spacecraft will return to Pluto, not just for a quick flyby, but to enter orbit and spend years studying this remarkable world. Such a mission could map the surface in extraordinary detail, examine the atmosphere over time, search for evidence of an underground ocean, and investigate how Pluto evolved over billions of years. Some scientists have even proposed advanced missions capable of using radar or other instruments to investigate what lies beneath the thick ice, although such technology remains part of future mission concepts. Every new discovery reminds us that the solar system is far more diverse than we once believed. Worlds that seemed frozen and lifeless can turn out to be active, complex, and full of unanswered questions. Pluto may no longer carry the official title of the ninth planet, but it has become something even more valuable to science: a natural laboratory for understanding planetary evolution, icy oceans, and the conditions that might allow life to exist far beyond Earth's familiar environment. Its greatest secrets remain hidden beneath kilometers of ancient ice. Until another mission returns, Pluto will continue challenging our assumptions and inspiring new generations of explorers. Perhaps the most exciting discovery about Pluto has not been made yet. The next chapter of its story is still waiting to be written.